Okay, we are on review over linear word problems, interpreting graphs, scatter plots, parallel, perpendicular lines, and we are on the third part. We are on the last part of this. So here we go. We are on page 204, number 17. Just come up. Just come. Page 204. Number 17. It says, here's what it says. 204, number 17. It says, the distance d in kilometers that sound waves travel through water is given by this, where t is the time in seconds. It says, make a table of values and graph the equation. Use the graph to estimate how far sound can travel through water in 7 seconds. So we need to go ahead and create a table, and then we are going to go ahead and graph this. So I get to choose my values. I'm going to go ahead and choose my easiest. Let's go ahead with 0, 1, 2, 3, 4, so on and so forth. So if I were to use this, my equation is d equals 1.6 t. Now typically I let you use calculators. If I were you, I would get in the habit of not using a calculator. So if I plug in 0, I get 1.6 times 0. That would give me 0. If I plugged in 1, I already know that that's going to give me 1.6. If I plug in 2, so 1.6 times 2, I go ahead and I multiply. That's 2, that's 3. I move how many numbers are after the decimals. That would be 3.2. So then 1.6 times 3, that's 18, that's 4.8. And then 4, so 1.6 times 4 is 24, that's 4, 5, 6, so 6.4. Now if I were to graph this, I would start at 0. I'm going to count by 1, 2, 3, 4. And this would represent my seconds. This would represent my distance. Because my y is d, my x is t. So here we go. 0.0 would be here. Now I get to choose what I count by. I'm going to go ahead and count by 1 as well. 1, 2, 3, 4, 5, 6. So at 1, I'm at 1.6. So I'm estimating. 2, I'm at 3.2. 3, I'm at 4.8. 4, I'm at 6.4. So it's going to create a perfect line. Now I could use my graph to estimate at 7, but I'm going to go ahead and I'm just going to plug in because that's going to give me a perfect estimate. So I'm going to plug in 7 to find letter B. So 1.6 times 7 is 42. That's 7, that's 11, so 11.2. So my distance would be 11.2. And that would be B. So here's my letter A, here's my letter B. I just plugged in 7 like I've taught you. We are on page 205, number 35. Page 205, number 35. So suppose y varies directly as x. So as y varies directly, this is a direct variation. So I'm going to draw an arrow down here. I know a direct variation is y equals mx. There is no plus b because I know the b has to be 0. That's what a direct variation represents. Typically the book, instead of the m, they put a k, but it doesn't matter. So now I'm going to go ahead and I'm going to plug in what they gave me. So they gave me y is 15. I don't know what the slope is, but I do know that x has to be 2. So I divide by 2, divide by 2. So that's 15 divided by 2. That gives me 714. Add a decimal, bring down the 0. That gives me 7.5. So my m is 7.5. So my equation would be y equals 7.5x. Now they said, now I need to find when x equals 8. So I'm going to go ahead and I'm going to plug in 8 for x. So 75 times 8 gives me 40. That is 42, 46. Move the decimal once because there's one decimal. So x would be 46. Page 206, number 44. And there's my number 44. Write an equation in function notation for this relation. Okay? So, the first thing is I need to find the equation. If I need to find an equation, I need y equals mx plus b. I need my m and I need my b. I need my y-intercept and I need my slope. So it's my y-intercept is 0 and my slope is up 3 over 1. So I already found my equation by looking at the graph. Now, I could also use 2 points. I could use 1, 3, and I could use 3, 9. This is going to give me the equation as well. Find the slope, 9 minus 3, 3 minus 1. That gives me 6 over 2, which is 3. So there's my slope. So that matches. Y minus y1, so this is x1, y1, so my y would be 3, my slope is 3, x minus 1. I can go ahead and distribute. That gives me 3x minus 3, add 3, y equals 3x, because that would be 0. Now function notation would just change the y into f of x. So instead of y equals, it's just f of x, and it would be 3x plus 0, or just 3x. We are done. Page 243. Number 11. Number 11. Writing an equation in slope-intercept form that passes through the given point and is parallel. Parallel. I need parallel. Okay? So my point is 3, negative 2. My equation is y equals x plus 4. Parallel means I use the same slope. So this would be my slope. Now I could go ahead and use point slope. Y minus y1, which is negative 2, equals m, which is 1, x minus x1. This becomes plus. If I distribute, I get y plus 2 equals 1x minus 3, minus 2 minus 2, y equals 1x minus 5. That's my equation for parallel. Number 23. It says write an equation that's perpendicular. My point is negative 3, negative 2. My equation was y equals negative 2x plus 4. If I want perpendicular, I need to find the opposite inverse. That would be positive 1 over 2. So now I can go ahead and use point slope and figure out my equation. So I'm going to draw an arrow up here so I have enough room. Y minus y1, so that would be plus 2, equals my m is 1/2 this time, x minus negative 3, so that's plus 3. Now I'm going to go ahead and I'm going to distribute. Y plus 2 equals 1/2 x plus 3 over 2, top times top, bottom times bottom. Now I can go ahead and multiply everything by 2. So that gives me 2y plus 4 equals 1x plus 3. Subtract 4. 2y equals 1x minus 1. 3 minus 4 is negative 1. Divide by 2, and I would get y equals 1/2 x minus 1/2. There's my equation, and we are done.